All right, let's talk about one of those incredibly important but kind of invisible technologies that make the internet actually work: quality of service. It's the magic behind why your video call can work perfectly even when your network is totally bogged down. So let's dive in and see how it pulls it off.
So has this ever happened to you? You're on a super important video call, and bam, everything freezes. But you know your internet is still up because emails are dinging in just fine. It's super frustrating, right? Well, the answer to that mystery is all about how our networks handle what's basically a constant digital rush hour.
Okay, so to really get the solution, we've got to understand the problem first. And the best way to think about it is this. Picture all the data flying around the internet, your emails, your Netflix stream, your video calls, as cars on this gigantic, never-ending highway. And yeah, a lot of the time is one big traffic jam.
So really picture it. You're stuck. Bumper-to-bumper traffic. You're just trying to get to dinner, but you're not going anywhere. It's that feeling of being completely stuck. Well, that is exactly what a busy network feels like, when everyone and their brother is trying to send and get data all at the same time.
And then, right in the middle of all that stopped traffic and noise, you hear it, a siren. There's an ambulance, and it needs to get through the exact same mess that you're stuck in.
And what do? We all know the drill, right? Instinctively, everyone pulls over. A path just opens up. We do it because we all get it. That ambulance getting to the hospital is way, way more important than us getting to dinner. It has priority. Simple as that.
Well, believe it or not, this is pretty much exactly what happens on the internet. See, not all data is created equal. The little bits of data making up your video call, that's the ambulance. The data for your email, that's you in your car heading to dinner. One is super urgent, super sensitive to delays, while the other, well, it can wait a bit.
Okay, so if the internet is just this massive highway, how in the world do we make sure the ambulances, our video calls, actually get through? Well, that's where the solution comes into play. You need a traffic cop.
And that traffic cop has a name, quality of service, or you'll see it as QOS all the time. It's basically a set of technologies built into routers and switches that does one job. It looks at all the data rushing past, figures out what's important, and then gives that traffic the VIP treatment to make sure it gets through first.
So the whole mission for QoS is to fight back against the three big things that just ruin your online experience. You can kind of think of these as the three main villains of our internet story.
First up, we've got packet loss. This is literally when bits of your data just poof, vanish, gone. Then there's delay, which you've probably heard of as latency. That's just the time it takes for data to get from A to B. But then there's jitter, and this one is so important. It's not just about delay, it's about the variation in that delay. Jitter is the reason a voice call can sound all choppy and robotic, because the packets are arriving all out of rhythm.
So how does our traffic cop, QoS, actually fight these three enemies? Well, it's got a special toolkit and a pretty straightforward three-step strategy to manage all that traffic. Let's break down how it actually works.
Okay, step one is all about identifying and marking. QoS has to figure out what's what. It looks at all the packets zipping by and stamps them, saying, hey, you're voice traffic, or you're just a big file download. Step two is controlling the flow. It's got to manage the speed, making sure the network doesn't get totally flooded all at once. And finally, step three is organizing the lines. It shuffles all that marked traffic into different queues, kind of like checkout lines at a grocery store, all based on the priority it set back in step one.
All right, let's zoom in on that second step for a second, controlling the flow. QoS uses two key tools to get this done. They sound kind of similar, but trust me, they are very different: shaping and policing.
And here's the absolute key difference. Shaping is, well, it's the nice cop. If you try to send too much data, it just holds on to the extra packets for a split second and sends them when there's room. It delays them. Policing, on the other hand, is the tough cop. If you go over the limit, it just drops the extra packets, throws them away, gone. And that is why you almost always use shaping on traffic leaving your network, because you don't want your internet provider to start policing and dropping your important stuff.
Okay, now for that third and final step, organizing the lines. This is really the heart of it all. This is where the actual prioritization happens, using a few different strategies to manage that digital rush hour.
The simplest, most basic way to do it is called first in, first out, or FIFO. And it's exactly what it sounds like. It's just a single file line. Whatever gets there first gets to go first. There's zero concept of priority, so our ambulance, it's stuck in the same line as everybody else. And you can probably see the problem here, right? When that single lane gets jammed up, the router just starts dropping packets to cope. And because there's no priority system, your supercritical voice packets have the exact same chance of getting dropped as, say, some unimportant background download. Not good.
So a much smarter way to do things is with something called weighted fair queuing, or WFQ. Now this method is pretty clever. It actually looks at the different types of traffic and gives more weight or priority to the small, chatty, interactive stuff. This makes sure that huge file transfers don't just hog the whole road and slow everyone else down.
But for the most critical data, the real VIPs, we have low latency queuing, or LLQ. Now this is the ambulance's dedicated, clear emergency lane. LLQ creates a special, strict priority queue just for that super delay-sensitive traffic, like your voice calls. Anything that gets put in this queue gets to go first. No matter what, it cuts the entire line every single time.
So, okay, we've seen the problem, the traffic jam. We've seen the solution, the traffic cop, QOS, and we've looked at the tools it uses. But what does this all really mean for you, for your day-to-day internet use? Let's bring it all home.
The whole reason QoS is so critical is that different types of data kind of have different personalities. Think about it. Voice and video packets, they are so impatient. They have to arrive on time and in the right order, or the whole thing falls apart. But a file download, which uses a protocol called TCP, is super patient. If a packet gets lost along the way, it just says, hey, can you send that one again? No big deal.
And this little table here really spells out why this matters so much. Look at a voice call. It's very high sensitivity to everything: delay, jitter, and packet loss. It hates all of them. A video stream is pretty similar, though it can handle a tiny bit more packet loss. But then look way down at the bottom. Email or web browsing. They have really low sensitivity across the board. Why? Because like we said, the protocols they use can just resend anything that gets lost. And this is the fundamental reason QoS has to exist, to prioritize the stuff at the top of this list.
So at the end of the day, quality of service really is the silent hero of the modern internet. It's this incredibly complex system, just humming away quietly in the background, making sure that our real-time stuff, our Zoom calls, our online games, our video streams, get the priority they absolutely need to work without a hitch. And yeah, that means that other, less urgent stuff sometimes has to wait its turn, even if it's just for a fraction of a second.
So now you know how it all works, and that kind of leaves us with a final question to think about. In your own digital life, with everything fighting for a piece of your bandwidth, your work calls, your online gaming, your Netflix binging, what data on your network really deserves to be treated like an ambulance? What deserves its very own VIP lane?